All right, welcome to our last unit, or concept I should say, in Unit 7. We're going to be focusing on limiting factors. We're going to be using again some of the calculations that we've done previously and applying it to a new scenario. Alright, so here we have a balanced equation. We can look at the mole-to-mole ratio of methane and oxygen and know that for every 1 mole of methane, we're going to need 2 moles of oxygen. But what happens if we actually had 6 moles of methane but only 4 moles of oxygen? Because of the mole-to-mole ratio, we would know that the reaction could only occur twice and then the oxygen would run out. So we can look at it in this format, that as soon as I run this equation or reaction twice, I have used up my 4 moles of oxygen. You can see that for every 2 moles of methane, we are reacting it with 4 moles of oxygen to get 2 moles of carbon dioxide and 4 moles of water. So because of this, since we started with 6 moles of methane, we now have 4 moles of methane that are left over or unreacted because we only used 2 of them. This means that methane is in excess in this reaction, and the oxygen is our limiting factor. This is what runs out first. So we know that by having our original values of 6 moles of methane and 4 moles of oxygen, because oxygen is going to run out first, that's our limiting factor of how much we can produce. So how do we determine the limiting factor? We can use a real life scenario here. Say you're making cars in a factory, and for every 1 mole of steering wheels plus 4 moles of tires plus 1 mole of frames, we make 1 car. So we know then that if we only have 3 moles of steering wheels, we can make 3 moles of cars. 6 moles of tires is going to give us 1.5 moles of cars, and 18 moles of frames is going to give us 18 moles of cars. I'm simply taking each of these values of moles and dividing it by their coefficient. And I can see then that the 1.5 moles of cars is my limiting factor. My tires are going to limit how many moles of cars I can make. And then our wheels and frames are in excess. So this is just like a little real life scenario to kind of help you make a connection between this whole idea of limiting factor. We could do this with, any type of product that we can make in the different parts or the reactants in order to make the final product. And we can always then use the idea of whatever's going to run out first is our limiting factor. So to determine the limiting factor, we simply divide the number of moles of a substance available by the coefficient it has in the equation. The smallest value then is our limiting factor, just like what we saw in the factory example. If the masses are given, we have to first convert to moles, which we're going to have in just a second. So we have a solution containing 10 grams of ammonium carbonate and 12 grams of nickel 3 nitrate that react according to the following. So here we have our given equation. Our goal is going to be to determine the amount of nickel 3 carbonate that's produced. However, we first have to determine the reactant that's going to be our limiting factor. So we have the amount of ammonium carbonate and nickel 3 nitrate. We want to know, again, how much nickel 3 carbonate is going to get produced, but we first have to figure out what's our limiting factor. So, since the values given are masses, we have to convert to moles and then divide by the coefficients in the equation. So this is going to be a little bit of calculating. We're going to be given their masses and converting them to moles so that we can see basically what's the smallest in the end. So we're first going to start with the ammonium carbonate. So we're going to have our 10 grams of our ammonium carbonate, and it's going to take a second to write a little bit of this out. Just like how we've been doing before, we're going to be converting from grams to moles. The GFM here we're going to do as 96.0 grams to 1 mole of the ammonium carbonate. And just at the same time, I'm just not filling in the formula here, but you should go ahead and fill that in on your notes. If we do that calculation, we see that we get 0.104 moles of the NH4 2 CO3 ammonium carbonate. And then we're going to go ahead and divide it by its coefficient. So the coefficient for ammonium carbonate is up here, which is 3, and we then get that this is going to be equal to 0.035. Alright, so now we need to look at how many moles of our nickel 3 nitrate is going to be produced. So we have nickel. And again, I'm not going to be writing out the formula of the compound just to save a little bit of time on here. So we're going from grams to moles. If we calculate the GFM, we should get 244.7 grams, which is equal to 1 mole of the nickel 3 nitrate. If we calculate that, we get 0.0490 mole of our nickel nitrate. Alright, then as we did before, we're going to divide by our coefficient. So dividing by 2, we get 0.025. Since this is our smaller value, that then means that our limiting factor is the nickel nitrate. So I'm just going to label this as our limiting factor. So that means that the 12 grams of nickel nitrate is what I'm going to use in order to determine the mass of my product. So now that I know that's my limiting factor, I can now go ahead and calculate the amount of nickel 3 nitrate that's produced. So we're going to use, let me go back to that. We're going to go ahead and use our 12 grams of our nickel nitrate over 1. I'm then going to convert that to moles, so 244.7 grams of the nickel nitrate. Didn't give myself enough room there. And that's going to be equal to 1 mole of our nickel nitrate. Alright, so now I have it in moles. I can go ahead, and this is just a mass-to-mass calculation. You might want to label that on your paper. This is just a mass-to-mass calculation. Okay, so we've done these before in a couple of our different concepts right now, so this should be mostly review. So if we have moles of nickel nitrate there, we're going to use moles of nickel nitrate below here. And then we're going to be going to moles of my desired target reactant, which is our nickel carbonate. Alright, so we're going to use the coefficients just like we would. We have a 2 for nickel nitrate, and we have a 1 for the nickel carbonate. So we can go ahead, and the last step is going to be to convert from 1 mole of the nickel carbonate to grams of nickel carbonate, which is going to be 297.4 grams of the nickel carbonate. Oops, sorry, I'm forgetting the 2 here. Alright, if we go ahead and calculate that, we know that with the 12.0 grams of nickel nitrate being our limiting factor, that we can only produce 7.28 grams of the nickel 3 carbonate. Alright, and that's it. So while there is a lot of work in terms of writing and calculating it, one of the calculations is something that we've already done, which is the second part. Really, the only new part is the first step where we're finding out what that limiting factor is. And we'll be practicing this a lot in class tomorrow, so jot down any questions you might have. Make sure you go ahead and complete your final summary for this unit.